Hello again. In this question, we are given that you have a block of mass m on which you have a semicircular cut. A body of mass small m rolls down on this semicircular cut, the radius of which is given to be r. The block rests on the horizontal frictionless surface of a fixed table. So this surface at the bottom is frictionless. Initially, the right edge of the block is at point x equal to 0. So this is x equal to 0. This is in a coordinate system fixed to the table. A point mass small m is released from rest at the topmost point of the path as shown in this figure, and it slides down. When the mass m loses contact with the block, its position is x and velocity v. So you have to find which of the following is correct. So, alright, so in this question, we will of course have to conserve momentum, right, because there is no friction. Also, to find the position, we can look at the center of mass of this system, right. So that will be interesting to find. So locate the center of mass of the system. What I'm going to do is turn this system into a complete plate of mass m dash, then 1/4 of a circle, which has negative mass. Let me call that m double dash, and here we have a mass smaller. In fact, let's try to calculate the center of mass without the small m, because then we would know how far it is located. But we are not given any information about the dimension of the remaining block. So in that case, finding center of mass will not help us. Let's start with finding the velocity of the block. That will be very easy to do. You can clearly see this will fall down a height r. So the potential energy lost will be mgr. This is the potential energy lost by this block. This will be equal to the increase in kinetic energy. And understand that when this block at the instance is going here, this bigger block will be moving this side, because initial momentum is 0 and the final momentum of this system must also remain 0, because the system has no external force acting on it. Right, so mgr will be equal to mv square, mv1 square by 2 plus small m v2 square by 2, and we know that mv2 will be equal to mv1, right. So what you can do is multiply with m on numerator and denominator, so you'll be able to write mgr is equal to, now mv1 is equal to mv2, so you have m square v2 square plus mv2 square. Here you have 2m and here you only have 2. So 1m can be cancelled throughout, and then when you take LCM, you see that v2 will be of the form, here you'll get 2m, which will come this side. So you have under root of 2mgr divided by small m plus capital M. So this is the value of v2. Using this, you can also find the value of v1, right. So as far as the velocity is concerned, you can see that option D is correct and option A is not, right. Now next, what you have to do is find the component of displacement of center of mass and the position of the point mass. So for that, to find the position, since the initial velocity is 0, since the initial velocity of center of mass is 0, you can be sure that center of mass will not have moved, right. Center of mass should not be moved because VCOM was 0 initially at the initial point, and you know that F external is 0. So velocity of center of mass is not going to change. Therefore, the displacement of center of mass of the system should be 0, right. Now this can give us an interesting insight about the center of mass of the block. So you see that center of mass, the x coordinate of center of mass, you can write it as m into x1 plus capital M into x2 divided by small m plus capital M. So the change in position of center of mass is 0, but this will be equal to m into delta x1 plus capital M into delta x2 divided by small m plus capital M. So what this tells you is that change in position of center of mass, right? So you can see that if this is the initial orientation of the block, right? So let's say the block moves by some distance and is now something like this. So the ball in this final position is located here, right? Now if this length is let's say let's call this y, because this is the amount we want to find. So you can see that this distance will also be y, the amount by which the topmost point has moved, and this entire length is r. So the displacement of this ball will be r minus y. Right. So in this equation, you will have m into r minus y. If this is positive, displacement of this bigger block will be negative. So minus m into y is equal to 0. So what you get is mr upon capital M plus small m. So this is the displacement of the block. Also it will have the minus sign, obviously, because it has moved in the negative x. Right. So additionally, what you know is that the position of point mass is, now if when you found the displacement of this, you can also find the displacement of this point mass, which is r minus y. So it will turn out to be mr upon capital M plus small m. So this does not agree with the option that we are given. So clearly that option is incorrect. So the two correct options are that the velocity is this. Also notice that they have divided m in the numerator, and that the displacement of this bigger block is given by this expression. So these are the two correct options.